Dinesh Rego. Hi Dinesh, and welcome to this special on cybersecurity. We're talking Fabric. Now, Fabric is a phenomenal approach to networking, right? Of that, I don't think there can be any doubt. It offers huge amounts of benefits to network administrators and organizations of all sizes. But what I really want to talk today about is about your love affair with Fabric, right? Every time I talk to you and I see you talking about Fabric, you light up. What is it about Fabric and the way it's architected that makes it such an attractive proposition when it comes to the topic of cybersecurity? What's that magic sauce?
Excellent question there, Isaac. So I've been working, like you said, I've been working with Fabric since its inception. And one of the key things that makes it special from a security perspective is that at the Fabric layer, we do not use IP. And IP, as we all know, is something that makes, that's kind of, it's like manna for hackers because they can use various IP scanning tools to get access to information about the network. So with the Fabric, we do not use any type of IP. It's all layer 2 communication, which makes it stealthy to any type of hacking attempts.
Hang on. So you're saying we're dealing with a TCP IP network, but there are no IP addresses on the Fabric layer? So how would you attack a network that doesn't have IP addresses?
So the way the Fabric works is there's the Fabric layer, and then there's the service layer, and the service layer is what provides you the transport for all of your IP traffic. So the Fabric itself is formed without the use of IP, and as such it's invisible to any type of hacking attempts, and it's stealthy, but all of your IP traffic is at the service layer, and it flows over the Fabric, which just provides, look at it as a highway that provides you a transport mechanism between point A and point B for your data over the network.
But that's not the only benefit, right?
Another benefit of the Fabric is that it uses a type of Ethernet frame that we refer to as MAC and MAC. And with this MAC and MAC encapsulation, the core of the network is sort of invisible to the edge of the network and vice versa. So what that means is core switches have no knowledge of MAC addresses that exist at the edge of the network. And similarly, any type of edge device that's connected to the network has no knowledge of the core switches that exist in the network. It's almost like these edge devices, end users, traffic from video surveillance cameras or IoT devices. It's almost like when they hit the Fabric, they enter a tunnel and they're magically transported across the Fabric. All they see is the walls of the tunnel. They can see maybe other devices that are in the tunnel with them, but outside of the tunnel, which is really the core of your Fabric, is totally invisible to them.
I get that. No IP, no MAC. Love it. And it's so easy to understand. Management plane. Tell me more.
So good point, Isaac, and thank you for reminding me about another important aspect of the Fabric. We have designed it in a way that we've separated the management plane from what we call the forwarding plane or the data plane. And what's the benefit of this? This means that any traffic related to managing the switches on the network are in a dedicated management service that runs over the Fabric, and it's completely isolated from all of the user data that traverses the Fabric. So again, another level of separation or segmentation across the Fabric.
So if Fabric was just about those three things, then that would be reason enough to jump to Fabric, right? But there's more, right?
Yes, Isaac, absolutely, because there's the benefits that Fabric has with segmentation and the separation of the control plane from the forwarding plane, and then the fact that the Fabric switches themselves don't use IP. But in addition to that, we can look at the network from a holistic approach and look at how do we provide end-to-end security with the Fabric. And the way you do that is you deploy the Fabric in tandem with the network access control system. So like a radius server where you control what users can get onto the network, you can control what services they get assigned to, you can apply endpoint security features, things like IP source guard, things like DHCP snooping. And in addition to all of that, you can also apply a bunch of policies that control the traffic from L2 all the way through L7 to control what type of traffic the users can send over the network. So we're looking at it not just from a fabric perspective, but from a holistic network perspective.
What I liked about what you said in the main statement was, again, the reference to end-to-end security. That is our NAC solution, which we'll look at later. Please tell me there's one more thing.
Yes, absolutely. Related to the statement I made about NAC, or Network Access Control, we actually provide service elasticity with the network access control. And what does this mean? This means that a service doesn't exist on the network or on a port of the network until a user is actually authorized or needs to belong to that service. So say a user or a device is plugged into the fabric, they get authorized by the NAC, and only then is the service configuration pushed to that port that that user or device is connected on. And then when that user or device disconnects from the network, guess what? That service is automatically removed. So that means that any type of hacker who goes and plugs into that port, plugs into a port that has zero configuration in it. Another level of security provided with fabric and NAC combined.
Yeah, that makes a ton of sense to me. You've explained it really well. Dinesh, thank you for coming onto the broadcast to expose the security magic of fabric. Thank you so much.
Thank you, and my pleasure, Isaac, and I hope it helped you and others that might be listening to this broadcast.